Hello, everyone, and welcome to KITE Research Rounds. It's my great pleasure to introduce our speaker today, Professor Martin Kampel. Dr. Kampel is an associate professor of computer vision at the Computer Vision Lab in the Vienna University of Technology in Austria, where he's engaged in research, project leading, industry consulting, and teaching. His research interests are trustworthy AI, 3D computer vision, and behavior analysis applied to ambient assisted living and visual surveillance. He co-founded 4 companies to bring successful research results into the market and to provide creative ideas and technology for product development. He edited 3 proceedings and is the author or co-author of more than 200 scientific publications presented at several international conferences and workshops. He served in many program committees for international conferences and as a member of the editorial board and referee for international journals and conferences. He is also an executive member of the Austrian Association for Pattern Recognition, which is the Austrian branch of IAPR, and also the IEEE. Please join me in a welcome round of virtual applause. And if you have questions for Dr. Kampel, you can type it in the Q&A box before you forget, and Dr. Kampel will answer them all at the end.
So thank you very much, Babak. Thank you very much for inviting me and also for giving me the opportunity to present some work, what we do in Vienna at the Computer Vision Lab. Today, I'm greeting you from the International Conference of Pattern Recognition, image processing in Abu Dhabi. So there was a little bit of a struggle with the different time zones, but as you see, we managed, and now I'm happy to give you a presentation on advancing AI in elderly care, balancing trust and technology. And to start with an overview, I will start my presentation in showing you a video with a very recent project which deals with the automated toilet assistant for people suffering from dementia. And I selected this topic because it has, or it provokes many questions, I would say. You will see that. And it also reflects our main research, which is behavior analysis in a very, very challenging environment. And what is really typical for our research is that we are not actually doing like data acquisition or in lab conditions. We go to the facilities. That means we have our installations in care facilities. We work with the people, with all the people involved, from the caregivers, caretakers, but also the managers. And that means we have to take care about many, many issues, from ethical issues till practical ones. This is quite special, I would say, since looking or choosing a way which involves all these different stakeholders is quite time consuming and needs a lot of energy. So I will start with that topic, and then I'd like to present AI as a socio-technical system. And you will see that I present quite some videos showing data we are acquiring. So what we actually working on is data-centric AI solutions. That means data is really the driving source, so to say. We acquire the data and try to learn from the data specific behavior patterns. That might be specific tasks when using the toilet, for example, as you will see, but we also had a very strong focus on fall detection. So we spent some, let's say, 10 years on fall detection. We also had a spin-off, which currently is in that business, basically means installing and selling fall detection sensors. I will kind of conclude with a vision on algorithmic governance of care, and yes, of course, will be time to answer a few questions. So to start with, I hope you can see that video. This video basically presents behavior modeling at the toilet to support independent use through instructions. What you see here is a caregiver and a caretaker. The caregiver basically tells the person who is suffering from dementia how to use the toilet. And we proposed to that specific use case an automated behavior analysis system. And what you see here is that the patient is somehow guided how to use the toilet. And this guidance, for example, here is given by a monitor who tells the person what to do next. And how do we detect all these activities? For that, we use a developed 3D sensor, which acquires range data, depth data. Depth data basically represents distance maps. So this is not at all a video, or it does not record any images. Everything you see here is a map of distances, and the distances can be in centimeters from the camera, but it basically allows us to do a full 3D reconstruction without showing any images of the person. So we detect certain activities, and based on these detections, we recommend or we tell the person what to do next. Yeah? And that is one maybe idea how to tackle that project or how to tackle that problem, so that people suffering from dementia might use the toilet in a much more autonomous way. And I'm showing you this video, and I guess this already raises lots of questions. Yeah? And that's why I show it, because I think in this video, all the problems are somehow involved. One of the first and main problems are privacy aspects. I mean, who of us would allow to have such a sensor installed in the bathroom or in the toilet? Or who would allow to have such technologies in the parents' home? So privacy matters a lot. And so who and user acceptance. So would you yourself accept such a technology which basically monitors scenarios which are quite private or which are very private? Then another difficult problem you saw was the human-computer interaction. So what is the best way to interact with the users? Here we show the monitor, but this is a big question if that is really the best solution, how we could interact with the people. Wouldn't it be better maybe to use audio, to use a voice, or to use music to trigger the next activity? So this open question, what would be the best human-computer interaction in that specific scenarios? One thing we always have to mention when we talk about technologies applied to elderly care is functionality. We had many, many projects in the last 10 years here in Europe, and I could review quite a lot of them. And many of these projects did not have proper functionality. That means it worked somehow under certain circumstances, but it was nothing you could really use on a daily basis. And also people who were using this technology did not understand why it is not really functioning. So functionality is a must and is a big challenge, I would say. Installation, maintenance, plug and play. Of course, these technologies, if really applied to care facilities, have to be easily installed and shouldn't need actually any maintenance. Yeah? So who is actually maintaining these systems? Yeah, it might be the caregivers, the staff who works there. They have already a lot of work to do, but they at least should know if the system is running or not. So these kind of things matter a lot. And then ethical and legal concerns. I mean, there is it's a huge question, or there's a lot of work done to investigate ethical concerns and, of course, legal concerns. That means all these projects we do here in this field are always in an interdisciplinary way. That means we collaborate with social scientists, but also with legal experts and people who are not at all from a technical field, but kind of support us in these activities. And then, of course, you need a proper risk assessment. So showing these videos is a nice, let's say, nice research project, but still, it opens a lot of questions. So how did we approach that field? So the idea or the context is basically that residents with dementia are accompanied to the toilet, but if a person comes with them, lack of acceptance, and also the assistance with this kind of daily activities can be very, very burdensome for the people who live with the person or who give care to this person. So the idea here is, as I said, is the step-by-step guidance for people with mild dementia in the toilet using this kind of death sensor. So how did we approach that problem? So in the first round, We interacted with focus group. We spoke with the people working in care facility. We spoke, of course, with the users, with elderly people. We tried, as technicians, we tried to learn about the users. We tried to understand how care facilities in Austria, for example, work, and how it would be possible to install or to have installations, prototype installations, demonstrators in such an environment. Then we developed the prototype in just one slide how it works. Basically, we did 7 categories of activities, and we built up a system which is able to recognize one activity of the other. So that means for each task, for each activity, like entering the room, approaching the toilet, sitting down, all these activities can be detected to a certain accuracy. And once one activity is detected, we have a given workflow, a pipeline, which triggers the next activity. So the system detects a certain activity and replies to the user if something is not, let's say, in the right order. So, of course, this system was also validated, and basically the activity recognition part worked quite nicely. So we had a nice accuracy of over 90%. And in lab conditions where we had, of course, we had students as users, this worked very nicely. However, when you go to care facilities, systems get these kind of things get more and more complex. And of course, it's not only the accuracy, which would refer to the functionality, it's many, many other things which you have to tackle. Yeah? This is actually an own topic, how to integrate or how to do these trials in care facilities. Much more difficult, and definitely the validation does not stop in accuracy. It deals a lot with acceptance and all the other points I raised on the slides before. So I said that we use 3D sensing devices, and I would like to talk about data, as I mentioned, but also about the sensing devices we are using. So privacy matters a lot, and we also learned that this also depends on the region or on the culture where you actually apply technologies. So we also had collaborations with Japan, for example, or Scandinavia, where we found out that people are much more open to trust technologies and to be willing to try things out. And that is exactly the opposite in Austria, and I would even say in Central Europe. People don't trust us. Yeah, even me, I'm someone from the university, and if I tell them we would like to investigate specific behaviors like fall detection, people reply and say, you're spying us out, you're spying at our daily activities. So there's a lot of how to say, frustration or mistrust involved, and that kind of made us right from the beginning working in a direction where privacy matters a lot. And I think already 10 years or even longer, 10 years ago, we stopped working with RGB cameras, no videos, no images anymore. We started to work with range sensing devices, for example. So this sensor is a typical 3D sensor. Of course, we started with the Kinect. That was maybe also 10 years ago. Now we're using other sensors. But the sensor plus an embedded board, that means we do all the calculations on board, close to the sensor, so that we don't have to transmit any data to any server or to any cloud services. So as I said, there is no camera image available, and we only measure the distances. There is, of course, no texture. And what we propose, or what we are able to deliver, is real-time analysis and no data transmission at all. And this is the final sensor design. So we also spent some time in making a proper design. It took us a couple of years to have a final design, which is also accepted by the care facilities. It offers quite some functionality. And we also noticed, I mean, it was also a very interactive, human-centric approach to develop this kind of sensor. As you can imagine, that there was a lot of feedback how the sensor should look like, and if there should be some blinking light or if there should not, or where it should be mounted, and this kind of things. So was one strong focus on fall detection. Again, you see one sample video where someone is falling from a wheelchair. We recorded data for more than 3 years, I would say. That means we have some more than thousands different fall situation. And again, as I said, we have a data-centric approach. We are relying on the data and we learn a lot from the data. I mean, for example, we have falls which take more than 2 minutes. So it's not something that a person just drops and falls. That can take quite some time until someone is on the ground. And of course, a robust system has to recognize this kind of situations as well. For example, we don't believe in accelerator-based solutions, since if a fall takes like 2 minutes, an accelerator simply just wouldn't work. So continuing with the sensor-based approach, as I said, we started with range-based sensing, and then we continued to another modality, which is thermal imaging. So the next sensor we developed is again, of course, a depth sensor, but we also added a thermal sensor. And instead of the Raspberry Pi, which was in the first prototype, we added here an NVIDIA Jetson Nano, which of course gives us more computing power. And same with the previous sensor, we are doing all the real-time analysis, all the analysis of the images recorded or of the data recorded, we do in the device. So we are not transmitting any data to any other processing unit. Basically looks like that now, since 3D printing became quite easy. This is a 3D print of that sensor, and we are using it now in care facilities. So coming to some kind of behavior, what kind of behaviors are typical? As I said, we spent some long time on fall detection. What I would like to show you here is behavior analysis, which relates more to relation detection. And we have here an extra actually use case. So it's not only care, this kind of behavior analysis with the same sensors we do in correction centers, in prisons actually. And behaviors are sometimes similar, but what we do here is that we detect the position of the person, that we detect the viewing angle, so in which direction people look, the pose of the person, the trajectories of the persons in the room. Also, we try to investigate behavioral, emotional behavior like aggression, which is really difficult, and other interactions of the person seen by the sensing device. That also relies on data acquired. In this case, now we have to acquire data from 2 modalities. That means thermal and range, and I will show you a few data samples how that looks like. I mean, a standard approach, we have that training data, and from that kind of data, we learn specific behavior patterns. This is very classical. So, for example, here you see a situation where the 2 modalities are compared. We have here 3D data and thermal images in a synchronized form, and that kind of reflects indoor behavior of 2 persons. And you also see a bounding box, which kind of visualizes, of course, the detection of the person. Another sample is given here. Here we have a group discussion. Actually, it's the ending of the discussion. And we have here a few persons who will get up soon. And I guess they will, it's more than 3 persons, as you see now. So these are typical situations which we acquire, which we have in our data sets. And from these situations, we would like to learn all the things I just mentioned. As I said, pose, some form of interactions, viewing angles, so to know who is talking with whom. But still, what is important to mention, we try not to recognize the person. So it still should be done in a very anonymous way. So we're not interested to learn who is who in all these situations, actually. Interactions are visualized like that. Now you see here 2 persons talking to each other, or even hugging them, and that also reflects how difficult it is to detect violent situations. I mean, we would have an idea that these 2 people are friends or having some fun together, and do not act against each other. And what you can nicely see here is the two modalities and also the pros and cons of each modality. I mean, range, is independent of illumination, so you don't need specific lighting for that. And you have the distances of the persons, and the thermal images, of course, could support any detection if, for example, persons are occluded, or you see just part of the person and you would like to have a robust detection, then the second modality helps a lot. Here we tried to combine the sensing devices together with a smartwatch. Basically, it was the heart rate. And the question here was if we can synchronize the signal of the heart rate acquired from a smartwatch with the visuals, with the images actually. The synchronization worked well, whereas the heart rate seemed not to be correct, because as you see, the one person who does some knee bends has always quite low heart rate, and we don't trust in the rate, but we see that the synchronization worked. Of course, if telling people to wear smartwatches is very invasive and actually needs specific permission so that you're allowed to get this extra data from the persons observed. But since that was a research project, we could manage to get this kind of data. Then we also tried to investigate violence, and here you see a simulated robbery that actually was acquired in the lab. Since that usually does not occur so often in a care facility or in a real world situation, we had to simulate such behaviors, and that brings me more or less to situations which do not occur very rarely. The same for fall detection. Usually people don't fall at the time, and I know for many solutions this is a big problem, that these rare situations are hardly recorded. So what can we do then? Then we use motion capture databases. So we model the data. That is also, I think, a classical approach, that you provide synthetic data which kind of delivers shapes, sizes of persons which you don't have in your data set. And that is, of course, also part of the training data set. From this, it's a short way to data synthesis of rare interactions. So we use 3D scans, reconstruct them, and rig them, and also animate them. So that also makes much more accurate training data possible. Basically, we rely on real acquired data, and just in specific situation, we refer to synthetic data. We believe that you learn most of the things from real situations. Just one word to the deep learning background. I don't want to go into details with that. On one end, of course, we use standard solutions. I would say that the effort mainly lies in the data here. However, when we develop our own solutions, one big necessity is that it is a lightweight model. That means we would like to have it run on a Raspberry or on the Jetson Nano. So that means we don't have large computing resources available. So that means it has to be lightweight and fast, so that we have the outcome in real time. And for that, we proposed one solution, which was a unified system of object detection and tracking, and that resulted in a quite fast solution, which was presented last year at the ICCV in Paris. So as an outcome of the behavior analysis in rooms, we have here one example of the real-time detection and tracking. We have here a reconstructed bird's eye view, and you see also the viewing angle of the persons. You see where they look actually, you see the speed, you see the direction, you see the location, and that somehow visualize, let's say, normal behavior. I mean, what is normal, abnormal is an extra topic, but as an outcome, we could show here how we were able to visualize or to record and analyze specific behaviors with multiple persons. What is maybe special here is, as I said, that we work with real scenarios. So that means we mount the sensor in real world in care facilities and produce the results in these environments. And I think that is a little bit different to that what you read when it comes to lab conditions, or when you have, for example, solutions or video material for a couple minutes, couple seconds, where you have a certain tracking accuracy or a detection rate. That's very much different to the situation when you mount a system which should run 24/7. Coming to the aspects of AI in care and how to reflect the topic of applying technologies to people in need for care. What are the objectives of these technologies? So of course, they should facilitate the daily work of caregivers. It should improve the safety of those in need of care. It should increase the productivity of care and contribute to the health and well-being of users. But that's not everything, of course. It is also expected or wished that it will reduce the cost of long-term care in the face of rapid demographic change. Demographic change, I don't know the numbers of Canada, but in Europe and especially in Austria, we have, I think in the coming years, 30% of the population are over 60 years, if I'm right. So there is a very strong need to tackle that problems. I mean, some people say technology won't help. At least let us propose some technologies. Maybe they support and can help at least me as a computer scientist. I'm hoping that technology helps, but this is an ongoing discussion actually. So what are the risks of AI in care? Of course, it's the depersonalization of care through algorithm-based standardization. We know that problem that we have standardized approaches. We might have the situation that people are not at all approached personally. Yeah? This discrimination against minority groups through bias, I showed you just one image on fall detection. We spent many years in that domain, but if you ask me, does it really work for people with wheelchairs or people with walking aids? Yeah, I have to say, yeah, yes and no. So there is definitely a bias towards specific group of people. The dehumanization of care relationships through automation. There's a lot of fear that for example, if we apply the fall detection solution, that people don't show up through the nights anymore. Caregivers trust the technology and say there will be a signal if someone is in need or someone needs help. And but the people in the care facilities are kind of waiting the caregivers to show up and maybe wish a good night. So the dehumanization is really a big topic when you talk with the people. Coercive control of users through surveillance. Yeah, so there is monitoring is a hot topic. So people feel monitored, and when you approach people, it's not that you approach only the users, the patients. You talk with the family, you talk with the managers of the care facilities, and at least in Austria and also in other countries, there's always someone who says that this is just a monitoring project and we shouldn't do that. So yeah, many problems, many risks. So to say, what are the challenges of digital humanism in care? It's the balance between personalized and technology-based elements in e-health and care. It includes the needs and knowledge of caregivers and care recipients in the development process. This is also, I would say, a very open topic. How do we as programmers, how do we tell our programmers, even at university, that it might be important to go to care facilities and have a look how people live, how the daily life looks like. This is still an open issue, I would say. The use of data for the management of care work, taking into account the GDPR, which is the General Data Protection Law in Europe, and the needs of end users. So legal The legal framework is important. But again, if I look at the developers, they usually don't care so much. So when you look at developers, or even the companies, one of the main things is, of course, functionality, robustness, speed, performance, and it is not so much how actually the technology is used. And this is, I would mention it as a problem. And here we involve a socially disadvantaged group in the digitalization process, which is definitely a very, very challenging task. So let me propose AI as a socio-technical system. A socio-technical system basically design and performance of any organizational system. Sorry, a system can only be understood and improved if both social and technical aspects are brought together. So this is really, I would say, a very important task, that social and technical aspects have to be brought together. I attended a few conferences in the area of social science, and I was the only computer scientist there. And here, for example, as I said, that I'm here at the conference of image processing, and today we had a talk on trustworthiness, and I did not see that there was a wish or expectation that this has to be discussed with social scientists. So I see here a big problem. AI is a modular ontogenetic system and not a singular technical artifact. That means what we understand here is AI, and I use AI here more as a general term for data. And data, as I showed it, is real and synthetic. We talk about an algorithmic model, which basically describes the algorithms, which is trained, learned, programmed to do something. It is the software. So how is the whole system used? There's also hardware involved. It's the sensor on the wall. And we have here diverse human actors interacting with AI. So we have very different group of people who are kind of part of that systems. So algorithms are systems that are composed of decentralized changing configuration of people and code. Data are never neutral, but instead value-laden. So what counts as data and what doesn't? So some questions relating to the socio-technical aspects. AI and care are really complex networks. So care work is a complex network. So we have the material infrastructure, we have care infrastructures, we have AI system, we have sensors, but we also have human activities, practices, and organizations. For example, care work, care organization, technology development, residents. And that also brings different perspectives regarding care and technologies. The perspective of the developers, who still have not so much insight in care practices. We have the perspective of the carriers, formal and informal, and at least in Austria here, they are very, very skeptical of everything we propose. We have the perspective of the managers who basically don't want to pay for it. And we have the perspective of the residents and users. So as an overview, I would like to show you these main terms of trustworthy AI, and I call it the algorithmic governance of care. So we have here the fairness aspects, which basically means that we would like the system should avoid data and algorithmic bias, and of course the system should not discriminate against any group of users. We have the reliability and robustness. That means system performs consistently and as expected across different scenarios. We have trustworthiness, which basically means the system is working and it also reflects the appropriate use of data. And accountability. That means clear accountability when the system fails. So these systems have to be safe, fair, ethical, and reliable. And coming to the end of my presentation, I would like to show you this video of a person who will fall soon, I guess, and it should reflect to the fall detection system. And this is the view of the sensor, and it also kind of shows how the system basically works. If we approach such a system, we have to question how fair is the system? How trustworthy is the system? Does it reflect privacy? Also, a big question is how explainable is it? Can we explain it? Do we need to have to explain it? Is it really interesting to know how it works? Yeah. So all these questions, yeah, have to be. We have to work on these questions. I would not say that the answer is easy. So there are very practical challenges, and this is, for example, explainability of technologies. Yes, how do we explain it? I mean, we went to care facilities and we did various things to explain or to show or to raise some interest in technologies, and there were very diverse reactions on that. Legal assessment. This is a very strong question when the managers decide to buy such solutions. One of the main questions, is it personal data? I mean, I'm referring to range data or thermal data. The question is it personal data? Can you identify persons or not? What is very, very important is interdisciplinary research. And I mentioned that I have the feeling that social scientists and computer scientists are not working or not collaborating too much. At least that's the case in Europe. I don't know how it is in Canada. Maybe that is much better. I think in your institute, this is much better since you are kind of combining different disciplines, which is really excellent. But actually, I'm not aware of so many institutions like that in Europe. So what is necessary? That care, technology, law, and social sciences collaborate, and that we exchange our ideas, wishes, and fears, so to say. Then what we also see here in Europe, there are many, many cultural and regional differences. For example, we did once a study where we proposed technologies in Scandinavia, which is like in the far north of Europe, then in Central Europe, Austria, Germany, and the southern part, yeah, Italy. And we asked them, how do you accept technologies? And in Italy, which is the very southern part of Europe, the people said, well, we expect the family to take care. We refuse any technology and any institutional care. The family must take care. And that means actually that the women are expected to take care. In the northern part, it was exactly the opposite. Yeah? One elder lady told us that she does not accept her family to take care about her. It must be public institutions, yeah, or technologies if we have some nice things working. And here in Central Europe, we are in between. So like in Austria, people are rather conservative and also expect the family to take care. But on the other hand, there are also some people who accept technology. So what I want to say that there are big regional differences, or for example, like that in Austria, Germany, and Central Europe, cameras are not at all accepted. But we know from many use cases in Spain or in United Kingdom in hospitals where cameras are accepted. This, like RGB videos, images, are no-go in many, many care facilities and hospitals in Central Europe. So you have these regional differences. And of course, technology acceptance and technological availability are also quite the challenges. I think also after like spending 15 years in that domain, I do not see so many solutions who work well and which solve, let's say, more sophisticated problems. So that brings me to the last slide. Technology, is it a contribution to inclusion or a danger to society? We know that technology can exclude, technology can be unfair, but the goals of technology development must be that it's technology for people, and we have to prevent discrimination, improve equal opportunities. And so I would like to thank you for your attention. Thank you very much. And I'm happy to answer your questions, of course.
Wonderful. Thank you for a very interesting talk. I really enjoyed. People in the audience, if you have any questions, you can raise your hand and we can unmute you, or you can type in your questions in the Q&A box and Dr. Kampel can answer them. And while we wait for people to type in their questions or raise their hands, I can start with a quick question. So for your ambient monitoring scenarios where you have either depth or thermal cameras, where do you do the processing? Are the images sent to a server and where you do the processing, or are you doing them on board? And if so,
yeah. So for a running system, all the processing takes place in the sensor. So we're not transmitting any data once it's running, yeah? But that means before you have that system running, you need training data and you have to train the model offline, yeah? And that's basically how it works, yeah? So what we also, this is like what we wanted to have is that all the computation and processing is local so that we don't have to transmit any personal data to any source. As I said, people were very, very skeptic about everything we do. So it said, on one hand, we do not use RGB or video. And second, we process everything in the device. And for example, if we would like to detect a fall or no fall, it's just a 0 and 1. We just transmit integers or binaries to say what's going on.
And thank you. And maybe a quick follow-up on that. So if it's all happening on board, then it has to be something that is small scale or that can be done on a small board, right? So can you maybe talk a little bit about the machine learning part that does the processing?
Yeah, so we spent really lots of time to have lightweight models, so to develop a lightweight model which is capable of doing this analysis on the Raspberry Pi or on an Jetson Nano. Yeah, so this it has a little bit more processing power. So the effort, or if you like, the innovation here was basically to have these models which run on these devices. Yeah, but again, the training takes place offline. So this is just that we copy the model and use it on the sensing device, on the Raspberry, sorry, or on the Nano Jetson.
Yeah, thank you. As you know, we work on very similar things, so I'm really interested in everything that comes out of your lab. I wonder if you can comment about generalizability and how well models that you trained, for example, in one setting translate to other settings when you deploy it in a different room or a different hospital or different.
Yes. So, I mean, what is clear from the sensing devices we use, we always have to work indoor. Yeah. So there is no way that you can use it outdoor. Sun is a big problem, for example, even not on terraces. So that means the scenery should usually have a size of approximately up to 8 meters by, let's say, 6 meters. That means usually so for fall detection, for example, we work with 2 beds maximum. Yeah, we have 2 beds in the scenery, and the models are trained to work or to deal with 2 persons only. Yeah, so the model is trained for specific behaviors. Yeah, for example, let's say 6 different behaviors. So one of them is fall. The second one is getting up from bed, or is rising up from bed, or is wandering around. Very simple things or very specific things, and the model can cope with only these 6 behaviors. Yeah, this is also when people say, okay, but you will also detect if the caregivers sit there and sleep, yeah, or don't work, you know, because that's what they say, that we watch their daily activities of the caregivers. We say no, we cannot detect whatever they do. Yeah, this is also not what we want to do. We really focus on, we call it modules, behavior modules, on these 6 specific modules, and these are offline trained and ported to the sensor, so to say, and that's it what we can. So it's, if you ask about how, I mean, generalized, it means it works in indoor environments with specific, not specific room configuration. If the room is full with bed and other luggage and so on, of course, the calibration might fail because the sensor has to see some flat part of the floor so that it is able to calibrate the system in a fully automated way. But it basically works in every room, and I think currently there are some 6,000-7,000 installations in Europe, basically showing that you can use it in any room. Yeah, but again, if you say, can we use it for 4 beds, or the room now is like 100 square meters, this is not within the range of the sensor, then it doesn't work. I mean, we also spent some time not only in combining the different modalities, we also spent a lot of time on occlusion handling. I mean, for example, you just see the legs of a person, and you still would like to know, or the system should know that there is a person behind the sofa, for example. So these kind of things, you know, right.
Thank you very much. People in the audience, I don't see any questions. If you have any questions, please raise your hand. Oh, actually, I see one now. Sorry. So this question is from Dr. Nancy Salbach, and they're saying, thank you for this insightful presentation. When you started work outside the lab to implement in care facilities, what concerns with using this AI technology were the most surprising?
Yeah, thank you for that question. I mean, from a technical, I have to start with the technical point because that was really surprising to us. The biggest challenge was connectivity. I mean, we spent years on training a proper AI model, and then we failed to deliver proper connectivity. Yeah, there was just the sensor was not reachable, which was from a technological point of view quite frustrating that we fail on that simple things. Yeah. What's surprising? What was really surprising to us is that people were so skeptic. So that was, I would even say, this is rather frustrating that technologies or this kind of technology is not well accepted in many European care facilities. Yeah, people. I mean, we use AI as a meta word for system, but there is a they don't trust the solution. They don't see the benefit. People also continuing to say that humans should take care and not technology. So these are very, very basic discussions, and that was, I would say, that was frustrating that we could not really continue. I would say to talk about real problems, and that we somehow got stuck in these basic discussions whether technologies should be used in these facilities. I think that was one of the surprising tasks that we could not really, that we cannot really convince the majority of people that this is for the benefit of people as we really believe in it.
Excellent. Thank you. Any other questions from the audience? Otherwise, I have to say this was a really interesting talk. I really enjoyed, and also very interesting to hear your answer to this last question as well, especially. So if there are no other questions, let's thank our speaker one more time in a virtual round of applause.
Thank you very much. Thank you, Babak.
Thank you.
Thank you for everything. We stay in contact. Thank you.
Thank you.